Again, welcome to Research Methods in Human-Computer Interaction. So one of our research methods will be stat analysis. So in these lectures, we are going to almost cover everything or all the topics in statistics. So our main objective is to go through descriptive statistics and also inferential statistics. Here we have comparing means, t-tests, analysis of variance, assumption of t-tests and f-tests. And that will be, again, our inferential statistics, including non-parametric stat test and also regression. So again, these lectures, we're going to cover the concept of using statistics techniques to, again, analyze your data in your research. So first is preparing data for analysis. So we know that, again, anytime we are going to start a research, especially if our task is a data-driven, then the first thing we need to do is to collect our data. So we need to go through the data collection process. Now we have to make sure that the tools we are going to use to collect our data and the measurements are very correct. And also we make sure that we avoid biases, and also the data should be well representing the population. Most likely we are going to collect a sample data, not the whole population. Using the population for research, it will be a time consuming, and also it will involve a lot of finance because population is very, very large. So to take time to collect a data of a population. So let's say we have to do a research in a specific region. The population is 100,000. Most likely we are going to take 5,000 should be enough, or sometimes less. So most of the time we do our research using, again, sample data. So after we collect our data, we need to do a cleanup process. So which we also call the data pre-processing. Especially in data mining or data analytics, we use the term, or in data science also, we use the term data pre-processing or data preparation phase. So here we need to detect any errors from our data. Also, we need to format our data based on the computer application we are going to use. So whatever statistics and application we are going to use, such as SPSS or Excel, or Strata, again, any type of software, we need to format our data according to the software application. Also, sometimes we are going to do coding. So let's say if we are going to do a quantitative analysis or parametric testing, I will need my data to be quantitative, a ratio or interval. So for example, if I have a gender and the gender is male and female, maybe because of my testing method or my analysis method, I need a quantitative data. So in this case, I can code my gender to be male is 0, female is 1. And we have a special algorithm in data analysis called neural networking. In neural networking, again, we need a quantitative data because our model that we are going to create will be a function. So coding the data, and also when we are coding, we need to be very consistent. Then after that, we need to organize the data. So here we're going to accommodate to the requirement of the stat software or the application that we are using. Next, we're going to do our descriptive statistics. The main goal of descriptive statistics is to understand our data set. For example, the measure of central tendency. We want to know the mean, the median, the mode. So the idea of the central tendency of the data set. Now, if my data set is categorical, then maybe I can only find the mode. Mode is based on the total tally, the frequency. By mean and median, we have to perform arithmetic operations, so we need a quantitative data. Also, the measure of spread is very important. This data will give it, this value here will give us how our data varies. So if I know the range is very small, it means the difference between the minimum and the maximum value is very small. So the data doesn't vary too much. or if I can find the variance and standard deviation and the values are 0, it means all my data sets have the same value. And if it's very small, it means the values are very close. Now, if the variance or standard deviation is very high, that means the values are widespread. So again, we use the measures of central tendency to know the average, the mean of our data sets. The measure of spread is based on knowing the variation of the data. Is the data, the values are the same or they are very close? So next we go to the inferential statistics. One of the common method we use in inferential statistics is a hypothesis testing. Also we use the estimation, and also we use the regression correlation. So first we start with comparing the means. These are some of the methods we can use. And most of all these methods, again, are hypothesis testing. So for example, we may have a sample more than one. If the sample is more than one, then we can use the t-test. So for example, if we are doing an experiment between group, which means we have at least 2 or more groups, if the independent variable for each group is only one that we are testing, and the conditions for each independent variable is 2, then we can use independent sample t-test. We also have the dependent sample t-test, so we call it the paired sample t-test. Independent sample t-test means we have at least 2 samples, at most also 2. T-test takes only 2 groups, 2 samples. The samples can come from different population. Also, the size of the sample can be different size. But if we are doing the t-paired or dependent samples, then that means the 2 samples must come from the same population. And also the sample size must be the same. So that's one of the techniques we can use. Another one, if we have the independent variable is only 1, but this time our conditions for each independent variable is 3 or more, which means we have 3 or more groups, then we can use one-way ANOVA. One-way ANOVA means our independent variable is only 1. Now, if the independent variable is 2 or more, and also the condition for each independent variable is also 2 or more, then we can use the factorial ANOVA. Then we also have what we call the within group. So between group, our t-test was independent sample t-test. But when you are within group, since we are using the same population, within group, we can use the paired sample t-test. So a paired sample t-test again means we are getting our 2 samples from the same population, and the size also are the same. So the condition for each independent variable will be 2. Then within group also, we have independent variable to be 1, but this time the conditions is 3 or more, then we also use the repeated measures ANOVA. Within group, if our independent variable is 2 or more, and also our condition for each independent variable is 2 or more, we can still use the repeated measures ANOVA. Now, if we are doing between and also within group, and our independent variable is 2 or more, conditions for each independent variable also is 2 or more, then we can use the split plot ANOVA. So again, these are some of the summary of the techniques we can use for hypothesis testing. Now, when we are comparing 2 means, which is the t-test, this can be the mean of the 2 groups. The most widely adopted method for comparing 2 means is again the t-test. We may, as we said earlier, we have the independent sample t-test, which is between group design. Then we have the pair samples t-test. It have to be within the group design. Because again, here we are using the same population, but we are going to take 2 different samples. Now, independent samples are normally data from different population or different size. So that's what we mean by the t-test. Independent sample means, again, the sample can come from different population, and also the size can be different. But dependent sample, which is the pair sample, the data normally come from the same population, and also we must have the same size. Now, the interpretation of t-test results, again, it depends on the t-value. So here we say that the larger the t-value, there's high probability of the null hypothesis to be false. So when the t-value is large, the probability of rejecting the null hypothesis. Also, t-value needs to be reported together with the degree of freedom and also the level of significance. So two-tailed t-test versus one-tailed t-test. Here we said whether the hypothesis indicates the direction, again, of the difference. So next is the ANOVA. ANOVA is the analysis of variance. Normally we use the ANOVA if we are comparing two or more groups mean. So it's also a parametric test. And here we use the t-test, we use the t distribution table. With the ANOVA, we use the F distribution table. So sometimes it's called the F test. We have the one-way ANOVA. One-way ANOVA is for between group design. Then we also have the factorial ANOVA. Factorial ANOVA means it's also between group design, which means different groups comparison, but at the same time, the independent variable should be two or more, and that's why it's called factorial ANOVA. With the one-way ANOVA, the independent variable is one, but the group again can be more than two or three or more than two. So we have an example of a factorial design here. Here we have a between group factorial design with two independent variables. Our independent variables here are the transcription and composition. This would be a task of data entry concept. So since we have two independent variables, and also we have 6 different groups, here we can use the factorial ANOVA. So we are doing between groups, we are comparing the groups, and also each group have at least 2 variables or 2 independent variables. We also have what we call the repeated measures ANOVA. And repeated measures ANOVA is good for within group design. Also, it can investigate one or more variables. So the independent variables can be more than one. Also, it's a form of one-way ANOVA. We also have the split plot ANOVA. Split plot ANOVA normally involve both between group and also within group factors. So it's good for experiment. So let's say we have 3 different groups and we have 2 different variables. This split plot means I can say, okay, I have 3 groups, 2 variables. I'll multiply 3 by 2, that will give me 6. So I can get a combination of 6 different sections of groups to compare. So what are the assumptions of t-test and f-test? Here we say the errors should be independent of each other, both for t-test and f-test. And also errors should be identically distributed. Identically distributed. Also, errors should be normally distributed. Now, next we move to identify relationships. So here we're going to go through the correlation and regression. So the whole concept of a correlation and regression is that we are trying to determine if there's a relationship between two or more variables. So for example, I want to know if cigarette smoking causes lung cancer. So I can measure the correlation of these two variables based on the data we have. So correlation means you have two factors are correlated if there's a relationship between them. And also most commonly used test for correlation is the PSC, product moment correlation coefficient test. PSC is a parametric test. And that's the most common. We also have the Spearman test, which is for qualitative data. So with PS, the range will be from -1 to +1. And also the PSR square normally represent the proportion of the variance shared by the two variables. So here they say we should identify a relationship. That the correlation does not imply causal relationships. So what we mean to say here is that maybe there can be a relationship between the variable x and y, but x doesn't cause y. There's no causal relationship. So example, we have age and two variable income or less experience in online purchase. And that leads to lower performance. So here the relationship between correlated variables and also an intervening variables. So how do we identify a relationship? First, we should know what is a regression. Regression normally are used to again predict values. So we can investigate the relationship between one dependent variable and multiple independent variables. So regression is used for two purposes. We can use it to design our model or model construction. And also we can use it for prediction. So different regression procedures, we have the simultaneous, and also we have the hierarchy. So with the simultaneous regression procedure, we find the relationship between the dependent variable and the independent variable as a group. Then all independent variables entered simultaneously. Then again, we get a sample result shown here. So here we have a model. The R here is the correlation coefficient, which is 0.858. We also have R square. R square normally gives us the percentage of the independent variable that can be explained for the dependent variable. So for example, if R square is 73.6%, which is 0.736, we can say that 73.6% of the independent variable data explain the dependent output. So the hierarchical regression procedure here to find the relationship between dependent variable and also each independent variable. So each independent variable entered at a time. Order of independent variables depends on the predefined theoretical model. So we have important IVs and also the covariance. And those are the two main things. So the order of IV, the independent variable, will depend on the predefined theoretical model. So again, the hierarchical regression procedure, this is interpretation of a result. So here, for example, we have a model 1. The R value was 0.565. The R square 0.319, that means 39.9% of the independent variables is explained by the result of the dependent. So 39.9% of the results of the dependent variable is explained by independent variable. And also the significance, again, means here 0. And we have degree of freedom for 1, and then the second degree of freedom 2 is 62. We also have the non-parametric test, which is also a hypothesis test, but non-parametric test is based on our data. So if our data is a qualitative data, that means everything will be based on counting or the frequency. So here we say non-parametric tests are used when the error is not normally distributed. Also, the distance between any two data units are not equal. And also the variance of error is not equal. And normally we have the chi-square test. A chi-square test is used to analyze, again, as we said, the qualitative or categorical data. So the table here is based on frequency counts, which we call the contingency table. So for example, here we have age, but instead of saying that age is 20, 30, 40 different types of age, we again categorize our age into 2, either less than 65 or greater than or equal to 65. So we have the preferred device, the mouse, again, is based on the counting, and the touch screen. So those who are less than 65, we find out 14 of them like the mouse, 6 like touch screen. Those who are greater than or equal to 65, the mouse is 4, the touch screen 16. So again, in chi-square, then the whole measurements or the process is based on categorical data. So as we all know, categorical data, we cannot perform, again, arithmetic operation. So this will be based on counting frequency. Now, how to interpret the result of chi-square is also based on the degree of freedom. And also the assumption of the test, we say data points need to be independent. Also, the sample size should not be too small. Then we have different types of non-parametric tests for comparing means. So comparing two groups of data, we can use so again, here we have some few non-parametric tests for comparing means. So for example, comparing two groups of data, if it's between group design, we can use the Mann-Whitney-U test or the Wolf-Wheat-Ron test. Now for within group design, we can use the Sign-Ranks test. Now, if we have more than 2 groups, so comparing 3 or more groups of data, now for between groups design, we can use the Kruskal-Wallis one-way analysis of variance by ranks. Now, if it's within group design, we can use the Friedman's two-way analysis of variance test. So the Mann-Whitney-U test, first again, is a non-parametric alternative to the independent sample t-test. Again, anytime we say non-parametric test, we mean to say our data that we are going to test, they are categorical or qualitative. So the interpretation of U value and normalization z-score will be considered also. So with the sign-rank test, it's also a non-parametric alternative. This time is to pair sample t-test. Again, as we said earlier, a pair sample t-test means we have 2 dependent samples or 2 groups. 2 dependent samples means both samples came from the same population. So if we have that condition and this time the value or the variable that we are testing is a categorical data, then we use the non-parametric. We also have the interpretation of the normalized z-score. Crisco-Wallace one-way ANOVA by ranks. Again, Crisco-Wallace again is a non-parametric alternative to one-way ANOVA, which means we have to have more than 2 groups, 3 or more groups. And we also have the Friedman's two-way. It's a two-way ANOVA test. So it's a non-parametric alternative to the repeated measures ANOVA, which is two-way. And this will be the conclusion of our lectures. Again, this lectures is based on the whole concept of stat analysis. Here we can see again, the only thing that we are missing here is probability concept. We didn't go details about the formulas and the procedures because again, this is a research methods in human-computer interaction course or research method in computer science course. So here, our main objective of this lecture is just to introduce the stat techniques we can use in, again, our research. If you want to know more details about the procedures we cover in these lectures, I also have a videos on statistics. We cover everything from descriptive, probability, inferential statistics. We cover hypothesis testing, non-parametric estimation, everything, confidence interval level, everything. So again, if you want to understand all the method that we mentioned here, for example, we talk about the central tendency, but we didn't discuss how we can, again, calculate them or use them. In my statistics video, again, we have all those topics. Again, thank you.